Okay, this is the Is It All There lab. You're gonna need some supplies. First off, make sure you have this handy, whether it be on the screen printed or not. This is the pre-lab you're gonna be filling out. Obviously, some of it's already prepped for you, the purpose, the materials, the procedures that I'm gonna be following today. And then your data table, this is something you can write in your journal or you can print and just fill it in. And your conclusion is also something you can write into your journal. So without further ado, I'm just gonna show you some of the supplies we're gonna use and tell you the point of the lab. So you're gonna need some sodium bicarbonate, which is just baking soda. You're gonna need some acetic acid, vinegar. We're gonna need a Erlenmeyer flask. This is gonna be used to help trap all the gases or anything that we're gonna be doing today. A balloon to help trap any gas that's escaping. Graduated cylinder so we can measure accurately the vinegar. And then a triple beam balance so that the point of the lab today is actually to see if mass or weight in this case is conserved before and after the reaction. So this is how you get started. You need some safety equipment, apron, goggles. We suggest gloves. Obviously these are household items, so in this case I'm okay without using gloves. So task number 1, I'm reading procedures. Number 1, pour 50 milliliters of NaCHO3, which is just your actual vinegar. Hit pause. Okay, one mistake to note is on the procedures, we actually listed pour 50 milliliters of NaCHO3, which is your baking soda. That should be vinegar. And then on step 2, where it says pour 1 spoonful of HC2H5O2, this is supposed to be your baking soda, okay? So I'm going to do the steps now to show you that. So step number 1, graduated cylinder. You're going to take some of your vinegar and you actually pour in 50 milliliters into the graduated cylinder. Obviously you want it flat on the table so that when you go to measure, it's actually the precise, accurate measurement. If you get a little extra in there, 1 milliliter or 2 is not too big a deal. You can always pour this down the sink if need be. I'm gonna slide by with just a couple of them, a couple extra milliliters. So there's our vinegar. Step 2 is to then take some baking soda and pour a spoonful into the balloon. You might need some help for this. I've had some practice. So the way this works is you take the balloon, you open it real wide, and you're gonna take it and put it into the bag or whatever you're using for baking soda in this case. And you can actually use 2 fingers and just take a spoonful. We don't want an extra amount, what we call a mountaintop, just as much as needed. This is plenty. Okay, and you're gonna open as best you can and pour in there. Obviously if you got some help, it's a little easier. Just baking soda, so if it touches my hand, no big deal. I'll leave it sit in there, and if I open it I can just shake it in to the balloon. So there it goes. Okay, baking soda, and then he gets on the table like I've got now. Once again, household item, not a big deal. So step 3 is to then place the flask of vinegar, which we have to pour in vinegar here shortly, and the balloon with baking soda and put them on the triple beam balance. So we're going to add our vinegar here. And then we will proceed to weigh this out. Okay, so we've weighed this out. We have our mass. We would end up adding this, your 100, your 70, and your approximate 7.4, and you would add that to your data table. And so that mass would be here, the mass before the reaction. And that's what you would write into this first part of the chart. So then our next step that is listed in the procedures is to place the lip of the balloon around the flask. Once again, you do need some help. You would leave the triple beam balance as is. We can stick it back on there, it should weigh the same. And normally you get someone to hold this for you, open it wide again, and then you want to put this on the lip of it just like so, without dropping any baking soda in. You just put that right back onto the triple beam balance. Our next step is then to carefully hold the balloon down on the base and to basically tilt the balloon so the contents fill in so we can watch the reaction. So you would hold perfect circle like this and you just dump in. So what's happening here is your reaction. Obviously we know this is a reaction because you're seeing bubbles, the gas that's filling into the balloon, and then if you start paying attention to the liquid, it's kind of hazy. There's some white stuff left on the bottom. This is baking soda and vinegar, so I can actually give it a nice little shake, make sure it's all reacting, all the baking soda is going away. And then once I see the balloons kind of filled partially or all the way filled up, I can let go. and then I try to record my mass once again. So at this point, you would move the triple beam balance to see if there's a change in the mass, and you would write it down and mass after reaction. Okay, so if we look here, we have our 100 or 70, and there is some change. So we're going to write this new mass, the 176.2 or so, into the after the reaction, and you would subtract these numbers and write the difference down. Now, the idea behind this whole reaction is there's a literal scientific law that says that whatever happens before the reaction, it should still be there after, especially if we've trapped anything that's supposed to be escaping all in here. Obviously, we already noticed there's a difference from what we just did, and there are a lot of mistakes with this particular experiment, and so I want you to point those things out. Where could we have areas where some of that stuff would disappear? Because it doesn't randomly disappear, it has to go somewhere, right? In this case, it goes into the air. So tell me what part of this apparatus or what part of this is where it could leak out or we can have issues with. And that leads you here to the conclusion. So you're going to see this massive equation here. All this is showing you what we did before, vinegar and baking soda turning into sodium acetate, water, and carbon dioxide. And the carbon dioxide is the gas that filled up the balloon. And the question is, the equation is balanced because. So first off, by the law that you see at the purpose at the top, you know that it should be identical because whatever you start with, you end with. And so we know that. Obviously, that's not what we saw. So you do have to state, we know the equation would be balanced because there's a law that states so, but why in this case it did not happen. And that's where we lead right back to the apparatus and kind of telling me why. And last but not least, you never blame the human. The human is not the error. If you blame the human every single time, and every lab we ever do past this, there's a problem at the beginning because the human's the one doing it. So you always talk about where the problem is here. And that is the lab, with the exception of a few other things on the conclusion. You just have to talk about the data, talk about your two numbers and what happened. Based on what I found, my data I know. Then you tell me, hey, the two numbers here changed, etc. Prove it. Tell me the numbers again. If I subtract, here's what I found out. And last but not least, it states, my conclusion is the law was followed even though. So this is where you're going to write that portion I told you about with the errors of this apparatus, okay? So just follow the conclusion, make sure you fill out the data table, and that is the end of the lab.